Hello friends, myself D Mahajan, Assistant Professor, MIT Aurangabad, presenting next video on second unit Inverse Laplace Transform. First of all, we define it. If Laplace of f of t is equals to f bar of s, given or we can obtain it, then that f of t is called as inverse Laplace transform and denoted by f of t is equals to, if you transfer this operator to right hand side, it becomes L inverse, therefore inverse of f bar of s, and it is equals to f of t. And here that f of t means it is a function from frequency domain is converted to a function in time domain, exactly opposite to whatever we have seen in Laplace transform. In Laplace transform, function from time domain is converted to a function in frequency domain. Here it is exactly opposite to that. Any function from frequency domain is converted to a function in time domain. Then we try to see some standard results or elementary results obtained with the help of the results of Laplace transform. First result, standard result for Laplace is Laplace of 1 is 1 by s, and therefore inverse Laplace of, when we transfer to this side, it is inverse of 1 by s is equals to 1. We get the first result. Second result is Laplace of e raised to at is 1 upon s minus a, provided s is greater than a. Then we get second result. Transferring this to right hand side, we get inverse Laplace of 1 upon s minus a as e raised to at. And similarly we have another result, inverse of 1 upon s plus a is e raised to minus at. When it is minus here, we get here plus at, and if here it is plus a, we get here minus at. Third result, Laplace of sin at is a upon s square plus a square, and therefore this constant term I will keep on the right hand side only, and therefore inverse Laplace of 1 upon s square plus a square means this term we have to transfer to left hand side. We get its value as 1 by a sine of at, or sine at divided by a. This is the third standard result. Fourth result is Laplace of cos at as s upon s square plus a square, and therefore we get here fourth result as inverse Laplace of, transferring this to other side, we get inverse of s upon s square plus a square as cos at, cos of at. Then fifth, Laplace of sine hyperbolic at is a upon s square minus a square, provided s is greater than a, and therefore we get here fifth result as inverse Laplace of, once again transferring this to other side, we get inverse of 1 upon s square minus a square as 1 by a sine hyperbolic at. Okay. Then sixth result, Laplace of cos hyperbolic at is s upon a square minus a square, provided s is greater than a. From this we get result number 6, inverse Laplace of s upon a square minus a square as cos hyperbolic 80. Last is the seventh result. We have two results. Laplace of t raised to n is gamma n plus 1 upon s raised to n plus 1, or if n is positive integer, its value is n factorial divided by s raised to n plus 1. Therefore, while finding the inverse, we subtract 1 from all these terms, and therefore we get seventh result, inverse Laplace of, I am subtracting 1 from this, therefore n plus 1 minus 1 we get 1 by s raised to n, and that is equals to transfer into left, we get here, subtracting 1 from this, we get t raised to n minus 1 divided by gamma of n plus 1 minus 1 means we get only gamma n. Or if we have this result, means whenever it is positive integer, n is positive integer, in that case inverse Laplace of 1 by s raised to n is t raised to n minus 1, t raised to n minus 1 divided by n factorial, n replaced by n minus 1, therefore it becomes n minus 1 factorial if n is positive integer. Okay, therefore 7 standard results for Laplace transform, and using these 7 results we can obtain these 7 results for inverse Laplace transform. I will take one example of this, how we can apply this standard result to find the inverse Laplace transform. Find inverse Laplace of 1 by 4s. Okay, and to find this inverse Laplace, we can take the use of that linearity property. Linearity property means constant term we can take outside, and therefore this inverse of 1 by 4s we can write down as 1 by 4, I can take outside as it is constant term, and inverse of the remaining it is 1 by s, and therefore it is equals to 1 by 4, and inverse of 1 by s is 1, and therefore it is 1 by 4 into 1, we get that value as 1 by 4. Okay. Second, find inverse Laplace of 1 upon s minus 2. Okay, and therefore to find this, we have to take the help of this result. Inverse of 1 upon s minus 2, here it is a with negative sign, in that case it is e raised to 80, and therefore as per that it is e raised to 80, a is here 2, and therefore it is e raised to 2t as its inverse Laplace transform. Third, find inverse Laplace of 1 upon s square plus 49. That is 7 square. Therefore, to find this inverse, we have to take the help of this third result. Here 49 means 7 square is 7, and therefore inverse of 1 upon s square plus 49, 49 means 7 square is equals to 1 by a, 1 by 7, and sine of 80 is here 7 t. Therefore, as for this, it is 1 by a sine 80, 1 by 7 sine 70. Fourth, find inverse Laplace of s upon s square plus 9. 9 means 3 square, and therefore applying this result, it is inverse Laplace of s upon s square plus 3 square, and as per this result, it is cos of 80, cos of a is here 3, therefore cos of 3t. Next, find inverse Laplace of 1 upon s square minus 4 means 2 square, and to find the inverse, we take the help of this result. Therefore, inverse of 1 upon s square minus 4 is equals to 1 by a is here 2, and sin h80, sin hyperbolic 2t. Okay. Six, find inverse Laplace of s upon s square minus 25 means 5 square, and therefore applying this result, inverse Laplace of s upon s square minus 5 square, it is equals to cos h80 cos hyperbolic 80 is here 5, therefore 5t. Then seventh, find inverse Laplace of 1 by s square. Power n is here 2, which is positive integer, and as it is positive integer, we have to apply this result. Its inverse, therefore inverse of 1 upon s square, as per this, it is t raised to n minus 1, t raised to 2 minus 1 divided by same factorial, therefore it is 2 minus 1 factorial, and therefore it is equals to t raised to 2 minus 1 is t raised to 1 means t, and 2 minus 1 is 1, 1 factorial is 1, and therefore we get the value as t. Okay. Then second, find inverse Laplace of 1 upon s to 3 by 2. Here that power n is not positive integer, therefore we have to apply this result, and applying that result, therefore inverse Laplace of 1 upon s raised to 3 by 2, here n is 3 by 2, as for that it is t raised to n minus 1, 3 by 2 minus 1 divided by gamma n, gamma 3 by 2. Okay, and therefore it is equals to, this is 3 by 2 minus 1, 3 minus 2, that is 1 by 2, therefore t raised to 1 by 2 divided by this gamma. To find the value of gamma, convert in the form of gamma n plus 1, therefore that 3 by 2 I can write down as 1 by 2 plus 1. Okay, and we know that standard result, gamma n plus 1 is n gamma n, and another standard value gamma 1 by 2 as root pi. Therefore these two standard results from that gamma function, and therefore it is equals to this t raised to 1 by 2 as it is. Okay, gamma n plus 1 is n gamma n, n is here 1 by 2, gamma n, gamma 1 by 2, 1 upon 1 by 2 that goes to numerator, we get this as 2 t raised to 1 by 2 and divided by gamma 1 by 2. The value of gamma 1 by 2 is root pi. Therefore this is the required inverse Laplace transform. Find inverse Laplace of one upon 3s minus 2. Therefore, this term in the denominator is not directly in this form. Therefore, we can convert in this form by taking 3 common, so that we get the coefficient of s as 1. And therefore, rewriting this inverse Laplace of 1 upon 3s minus 2 is, I am taking 1 by 3 common. It is inverse of remaining term. What is the remaining term? When we take 3 common, here it remains s. When we are taking 3 common from this 2, it remains 2 by 3 there, and therefore it is 1 by 3 inverse of 1 upon s minus a. Applying this, it is e raised to at. A is here 2 by 3 times t. This is the required inverse Laplace. Find four s plus root 2 divided by s square plus 9. Find inverse of this. Okay. Here there are 2 terms in the numerator. Therefore, dividing separately, we get inverse of 4s plus root 2 divided by s square plus 9. 9 means 3 square. Separate division, and then applying property of linearity. 4 constant I can take outside. It is 4 inverse Laplace of s upon s square plus 3 square and this root 2 constant outside inverse Laplace of 1 upon s square plus 3 square are dividing separately. This divided by this divided by this, and taking constant term outside. And then applying the standard result, it is equals to, for as it is, s upon s square plus a square, its inverse is cos of 80. Therefore, it is cos of a is here 3t, a is 3, therefore it is cos of 3t, plus root 2, 1 upon s square plus a square, its inverse is 1 by a is here 3, therefore divided by 3, and sine of 80, a is here 3. Therefore, this is the required. Find inverse Laplace of s square minus 1 by it is s square minus 1 bracket square divided by s cube or s raised to 5. Consider s raised to 5. Find the inverse of this. Therefore, it is not directly in this form. We have to rewrite it, expand it, and then dividing by s raised to 5, we get this is L inverse of s square minus 1 bracket square divided by s raised to 5, and therefore it is inverse Laplace of expanding a minus b whole square, a square means s raised to 4 twice ab, and b square 1 square, and divided by s raised to 5. Okay, and then dividing separately, we get, therefore it is equals to, means it is inverse of s square minus 1 bracket square by s raised to 5 is equals to, dividing separately, we get it is inverse of, and finding separately inverse, s raised to 4 by s raised to 5, we get 1 by s, then minus 2 constant outside, inverse Laplace of s square by s raised to 5, it is 1 by s cube, and 1 by s raised to 5 plus inverse of 1 by s raised to 5. Okay, and then applying the standard result, inverse of 1 by s is 1, 1 by s raised to n, where n is positive integer. Therefore, applying this, its inverse is t raised to 3 minus 1, 3 minus 1 we get 2, divided by same factorial, that is 2 factorial, plus again 1 by s raised to 5, applying this as n is positive integer, it is t raised to 5 minus 1, we get 4, divided by same factorial, that is 4 factorial, and therefore we have, it is 1 minus t square by 2 by t square by 2 to get cancelled, we get only t square, and here it is t raised to 4 factorial 24. Therefore, this is the required inverse Laplace transform. Therefore, with the help of this simple example, I have explained how we can use this standard results or elementary results to find the inverse Laplace. Throughout this chapter of inverse Laplace transform, we have to apply this standard result. In my next video, I will explain how we can use the theorems of Laplace transform to find inverse Laplace transform. If you are watching my videos, please like it, share it, as well as subscribe my channel for latest update. Thank you.